Say hello everyone, thanks for joining. And yeah, this day will be about the simulation. We will simulate the bridge and we'll go through how those things are done, and it will look quite cool for us. We will look how that is done in a second. All right, so I'll be right back. So what we will do first is go into Houdini and try to understand where we could start our simulation the best way possible. I feel like we could do it before the sweep operations. And now will come some cleaning. So Shift C, this will be a subnet. I will call that subnet make planks blue. Here we go. All right. So this will be a calculation or a separation. Let's keep it to dark gray. That's fine. Let's put those into one as well. Those have colored. All right. So split here. That belongs into here. And yeah, this whole operation is the same operation. So let's do it all together. Let's group them. Shift C that, and wait, it didn't work. Shift C. This will be called weight painting. Weight painting. Red. It's fine to call it red, and we'll keep it in dark gray. Let's put those two bad girls together. And here we go. Yay. Cool. Then let's see. We have here materializing something. So all of this, I mean, it's fine to stay outside, honestly. It's cool. Let's keep them outside. Let's let them hang outside. What do we have here? This is the randomization that we created. So let's put it all together. Excuse me. Randomization of the UV. So let's put those together. Right there. So Shift C. Whoa. That went away. Shift C. Woo. Damn. Okay. Shift C of here, maybe. Shift C. Yeah, this works. All right. And let's put this here. Click on Alt. Put this thing here. Okay, this one on the left. Here we go. I mean, delete this, fine. Doesn't matter. Yeah, let's put those together right there and flip them. And again, right there. Let's put one of them down a little bit so it's not intersecting, so we know where things are going. Probably should have put the other one down. Let's see. Now we're gonna put you down. No? Okay. Let's see inside of here. Whatever. Yeah, let's keep it right here. Okay, good. It's just not gonna work, so let's remove it. What else is there? We have subnet, so this is doing the UV randomization. Good. We have that. It will be gray. Cool. Yes. Good. Enumerate, we did that yesterday. We have created this system. We'll keep that system just in case we need it. What else did we do? Because we are not using it, it's gonna be dark here. Turned off the light, so to speak. Yeah, okay, this is a bit more organized now. The sweep gen here, we will be working right there in the simulation, so let's put some stuff to the right side a little bit, so like here. Yeah, so it's not too complicated. All right, so we have the sweep generation here. Let's give that a red Actually, purple is the color to put this in. Actually, what's that color? It's purple. Okay, let's put that into purple as well. Yeah, and now we have sweep gen, which is the rope gen. Okay, and right before that, we will be working with the primitives or with the lines. I don't know what they're called. So let's create a null in here, null. And that null will give it a... What is the color we should give this? Let's actually put it all the way to the right. Let's make simulation pink. I mean, pink we've used before, right? It's right there. We've kept this. Yeah, keep this, I guess, into black, right? Because it's turned off. Actually, don't give it any color. It's fine. Just bypass it. This way we know it's not going to work or it's not working. Wait a second. Okay, so now we have a null. And that null... Let me just check on the sound. Hopefully the mic is not broken like yesterday. Good, mic is working. So let's keep working. Null is here. Amazing. Let's see where we can take this from here. Let me think a little bit. All right, so basically, let's view what is inside of this null. It should be out rope line, right? Here, okay. Let's view that. Yes, it's just the ropes. Yeah, just the sides of the ropes, no poles until now. And we will probably going to add the simulation right here in the beginning. Okay, so let's do that. I'll be right back, learn a bit more, and let you all know about my learning process. Okay. All right, so now we know a little bit about simulation. It's still introduction level, so I will be struggling for quite a while. That is the part of the stream and of those recording is to struggle together. Okay, let's see. Let's go. Tap. And then we will add split, because we need to split our nuts away from the rest of the geometry. Let's look at our null. Here we are. Take the rest of that and check our... Let's take our nuts, upper nuts. Here we are. We split those. Now let's put another null after here, and this should be only rope. So split rope. This one should be split nuts. Split. Just so for later we know what we're doing, right? So we split things, and now we will add the simulation nodes, which are one of them. We will start with Vellum solver. Vel double L O U M and solver. All right, so this should solve the vellum, so to speak. I still don't know what that could mean, but we will see it together. Sorry, not the vellum solver, but before you put a vellum solver, you need a vellum constraint. So let's do that first. Vellum constraint. Constraints. Okay, so let's put it here, and it's told to us to use the instead of the taking constraint type distance along edges, we will need constraint type string. And now we can hook up this here, and it should work. And then we will take that constraint and take its data, hook it up here, and then press on this, take it to frame 1 and press play. Wait, and here it is, it's working. We have a vellum solver, so to speak. Go back, play it again. Yep, it's working. Now we need to add some logic to it, and I will know more and let you all know some more stuff. All right, some exciting stuff we have learned so far. Okay, so let's get into it, everybody. Let's check first, what is the split doing? It's splitting the rope. Now, what we want, and I'm going to make a screenshot out of this so y'all can see what's happening. Let's do it together. Here we go. I'm finally getting some energy back again. And okay, so what we want to add a pin, so to speak. Like imagine something is pinning this here, right? How to do a pin, how to draw a pin. I guess like this. Yeah, that's fine. Okay, so we need to pin this and pin this. And here we go. Boom, 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 boom. Wait, it completely, yeah. Here. Ah, right there. Good. All right, just to add some perspective, satisfy the artist on the stream. See, we could draw. Cool. Let's have those. Good. Let's add some shadow, just because. Why not? All right, we can't add shadows. Let's forget about that. Good. Another pin we will add here. Again, just a fast way to draw this. And another one here. Now we're not satisfying the artist anymore, but it's fine. Just for the sake of simplicity, we'll go with this. So yeah, we need to pin those, also those and these, the ends of each one of them. And then this whole thing should then fall this way. And yeah, it will look like this. All right, let's draw. Let's get that working like that. Okay, so let's hope this will work for us. Let's get to work. First of all, we need to split the upper rail from the bottom rail. Clear, split, boom. Here we are. Let's see if we have created groups for those. If not, we will have to create a new one. So upper rail, lower rail, amazing, cool. Let's view those in here. Are we splitting? Yes, we are. Now we need a group by range like we did before to split the ends. Group by range, here we go. And we will view our selection, take our points and their numbers. What we will do is turn this to points, give it a name of, I don't know, pins. So our pins that we created, these 1, 2, 3, 4, right? So those are our pins. And now we pin them for the simulation to work. Let's go back here. And the way we do it is we'll say affect disconnected geometries separately. And this should so far give us the ability to split those into different points, right? Let's enter here, enter. And now we need to select by range. So let's see, start 1 and 1, and we will invert range. Here we go. And this should now create our pins, and it will only create the logic in the volume constraint. And now we'll go here. And we will take as a group, we will take our diagonal rope, lower, wait, did it not save the name, group name, our pins? Let's do it here too. Let's check again. Yeah, here we go. Might still work, might not work. Let's give it a try and we will lose nothing. So let's just save and give it another version as well. Week 2.1 and go. Okay, yeah, kinda. Nope, it's not working. Okay, so let's view what we have missed. Well, that is totally fine to miss something. So let's check it out. I think it must be somewhere here where you have to change an option where it works. I mean here, sorry, it must be here. Oh wait. We have actually selected the wrong thing. Let's Control Z some stuff. Control Z some stuff until we're back. Yeah, okay, our pins is there. Good. Let's go to our volume constraints. Yeah, it should be here. This one. Just we need, I think, to create something here. Well, let me Control Z that and we'll go through it one by one. I feel like the groove is switching to points. Okay, so yeah, I'll watch some more and we'll let you know. Okay, I've been fooled. Nah, not really. Okay, so basically, instead of putting geometry group, you will have to go down into the pinpoints right there, and those will be our pinpoints, so our pins. Good, and now we go to our Vellum and play that. Woohoo! It has some bounds. I love it. Cool, guys. We made this thing go down. Let's do it again. Yeah, but now it's definitely too fast, I would say. How to make this bigger? 124. As this work? 124. And copy that. Yes. Okay, let's play that again. Yeah, it's how fast it is. Definitely has mistakes. This is not unnatural, like a bounce here. So we'll go through that together. Let's check it out. Let's learn some more. It's working at least. That's cool. Before it gets too complex, let's get into it. So basically, the next step should be basically to go back to our split. Right there, we have split our nuts. Let's keep that split going. Then we have a split here where we've split our ropes. And let's take the data out again and add a null, basically. And this will give us the diagonal rope. Diagonal rope. All right, so let's do it properly. The rope, maybe ropes back because it's got to be regardless. Ropes back. Rope split. Here we go. Actually, it's walls, ropes, split. Okay. Yeah, that's the over, so to speak, like the main thing. Okay. Now we will keep our pins as a group. We will check if we have a wall group for this. Let's see, diagonal rope. Yeah, we have one. It's called diagonal rope. That's exactly what we need. Let's then take this in the middle to visualize it a little better. Then we need a merge of some sort again. We will put that merge right there. Let's take our ropes back. We have created our pins. That's perfect. Now we need a logic that basically not only pins those, but glues those points of the diagonal line on the point of the of the upper and lower rope. So let's add something called, as you might think, Vellum glue, basically. Vellum glue. Let's get that glue going. Let's put it in the middle here. The glue will work like a glue. It has, but first, let's just see what it's doing, because every vellum has the chance to. Let me check. Glue, yes. Let's check. Where is this thing? Give me a break. I'll to recording. Okay, so we can visualize things here in the solver. If you go from solver to visualize and enable our wheels, in case we have them, let's enable all of those. And we will see basically the visualization of things. Let's put the radius a bit bigger. And now with the glue, we should be able to choose our points groups and take our pins, I think. Although primitives, let's check. We'll take our upper rail and our lower rail and glue it to our diagonal rope, this one. And we will allow to have stretch and enter here to view things. So this thing should show us what is being glued and where. For now, we don't have any glue working because we haven't set it up correctly yet. Let's see, what else do we need? Let's glue the points together. Nah, it is a primitive, okay. And let's do a search density. Let's make it higher and check if it is working. Basically, we just want those points to glue. So let's go back here. Let's give it more values in the glue part of it. No, here, sorry. Let's give it more density. Let's see if this would work for us. Click here. No, it's only working here, so it won't work. Okay, give me a break. I'll check it out. Let's check it out. If we keep playing with it, maybe it would work. Point, and these need to be points as well. All right, search density, let's go a bit upwards. Let's visualize our stuff and maybe give it a try. Here we go. Yeah, that's not working. We need a way to make our grouping and our group points as well types correctly. We have diagonal rope, which is a primitive group. We need that into a point group. So how to change that? Let's make a group here. Let's change it to a point group and let's call it rails. Okay. Okay, so we have a rails group and it's a point group. And here, let's create a group as well. Let's call it up and down, and let's make it a point group. Up and down. Cool. Let's put that here. Why are we getting the error for? Up and down is not a valid name. Okay, up and down. Okay, it's fine. Whatever. Let's keep it like this. All right, whatever. Let's go here. Okay, let's check for, let me think. We will. All right, I was just thinking a lot of it now. We created the groups, right? So let's go to the glue and shows the right ones. So up and down, delete the rest. Points, let's take the rails. Here we go. Let's delete that one. Now we have points. Let's visualize this. All right, so what is happening here? Why are we not? Oh, okay. Here we go. Yeah, they are gluing. That's good. Let's play again. It will load. Yeah, we are achieving something, definitely. We're getting there. That's a good result. We just need the search to... Okay, so what I will do is add another one. Let's dive deeper. Let's go inside of the simulation. Let's just put it inside a box because we need some type of visual cue to follow through. Make it black for now. Just for us to notice that we are working on this visually. Okay, now let me think. We need to work with the glue and visualize this though. So keep us here, please. Go back in the hierarchy. Where are we, man? Oh my god. Right there. Side of here. Okay, keep the visualization and let me just play with this. Oh. Let me think. This will be with 2. So when I will click here, it should not update. And now it should not update. Why is it updating? This is 1, dude. Leave me alone. Huh? Why? Try to think. Why is it not working? Let's see. Yeah, I don't want to switch between them the whole time, but it doesn't matter. We're gonna do it anyway. We're gonna do it anyway. So let's do it anyway. Glue. Let's go. Let's go with 5. Let's go with a less value here. Check what happened into the 1. See if this would do it differently. It's definitely different simulation happening. So I will learn more and let you know. All right, we'll go step by step with this thing. Let's see, step by step, Jack. Don't stress, there's no need to. Let's go one step forward. So here, what we don't want is this here. We want to get rid of that. One thing we realized here, this one too, we don't need those 2 here. There are a couple of ways to change it, but let's go with the first one. Let's go with our glue and change the way we group things. So instead of having up and down here, we'll have it down there. So this will have rails, and the other one will have up and down, and delete the rails. Here we go. Now we will go to our visualization. We see that we are a bit closer to the result. We'll go back to the glue again, mess with our settings here. Just a bit more values, still the same. We notice some of them are even gone now, and we need that back to it being workable. Let's go back again. Yeah, our points are back. We can see the purple is the pin. The yellow stuff are the gluing points. One way to solve this is to add resampling, but this will mess a little bit with our rope creation. I'm thinking now to just follow without the resampling, to follow along and resolve this issue with, well, let's see first. So he basically solves it, and we will go through it. Oh, I hit my mic. Does that mean Twitch will give me now poor sound? No, the sound seems okay, honestly. Let's check the quality. Why are we getting so... Why is the video so slow? Basically, the whole internet is slow. Yeah, my Chrome is lagging. Oops. I hope it's not like that on all the screens. I need to check. Maybe I check on my phone. Maybe I should check on my phone just in case maybe the PC is struggling. So we'll just check on my phone if the quality is quite well or not. No worries. Then let's keep going. Yeah. One way to deal with this is to add a resample. And that resample could be on our up and down grouping here. Let's remove that. Let's give it a maximum range and give it more, like until it fits. You could see like here, it is right on point. And then let's see if that solves the problem in the Vellum. It does to some degree, of course, but not fully. Maybe we need the other resample to happen as well on the other side in order for this to work. So let's do it. Let's make it happen on like before. Let's add that. Let's just view it. Walls, rope, split. Why are we not seeing it? Let's see. Okay, so yeah, one or the other, and we need to enable this one here. Okay. Okay, yeah, we need something like this maybe, and let's check our Vellum. Okay, so we're gonna try that grouping method with basically creating a new group that is the same way here. And then we will put that beneath it, put the group upwards just like we did in the other one. So we have the same workflow, so to speak. Then we need a group transfer, this thing. Then we will take this out and take the edge groups out, so primitive groups out and edge groups out, because we only are dealing with group points. And now, why are we not seeing this? What is happening? What is the error here? Not enough sources specified. How come? This is a point. Okay, what about if we put this here? It's still having the same problem. Okay, give me a break. Because I don't know the node yet and how it works, and it's just part of it. We will get to know it now. Okay, so let's put our group on the left side. Actually, you know what? We take our resample here. Okay, and now we'll put our group in the middle and connect it again. Now we will have enough information to work with. There we go. Let's go with the rails, our group, and this should... Let's see, what else can we do? Give me a break. Let's see what the transfer does. Let's press enter and take that down like to 0, 0, 0, 1. Let's check what is this doing. If I press enter, let's view it first and press enter. Let's see. I can't really see anything happening. So I wonder what's happening. That is what's going on in the course, so we will just follow it. Bits and pieces there, bits and pieces that are missing. So let's go over it. And instead of skip group, we'll overwrite. And here we are. So if I take that bar, it will select everything, and the lower it is, it will select only the end, so to speak. But why is it doing that? I really honestly don't know. Why is this the case? I mean, if we just try to understand it, it's a group transfer, so it's working with the points groups here. Group name conflict override, distance threshold. Maybe it is working with the distance from point to another point. Maybe. And yeah. All right, we will see. 001. And in this way, we have a group to work with. And let's see how that will transfer to the glue. And what can we do with that to change the method? Is there a way to take our rails here? Let's see. Maybe something will change. We'll be right back, people. Let's see if it worked. So far, nothing else we need to change. We just need to view it. Maybe we need to change a couple of settings to make it work. We see that it's quite less now. Rails check. Let's do it again. Rails in the Vellum glue. And up and down. Let's change our method here slowly until it works. Still takes 2 points, whatever the reason for that is. Probably... Okay, do I need to put more resample value here for this to work? 150? I don't know, just trying to guess here. And yeah, it's closer, but... Yeah, that kind of solves it, but not entirely. I mean, it's not... Where can we do that threshold thing? Minimum search distance. Let's do the minimum search distance to 001 and the maximum to 002. Let's see how that changes things. No. Let's take it to 1 here and 1 here. Maybe this is 2. Let's check how that works. Yeah, we're getting closer into the points here next to each other's, but not quite there yet. Let me try to think. Glue. Yeah, max search points 10, 2. nearest, farthest, constraint per point, detach, object chance, detach point chance, seed stretch 1. Let's put this to 10. Yeah, super duper stiff. Breaking, let's go to here and make this, I don't know, let's do this 1 here and 2 here. Let's check what's gonna happen. Okay, that's funny. How are we viewing that now? Funny. No idea. But it worked. Let's see what we could do. Minimum, maximum. Yeah, this should not exceed that. Let's go with it. Okay, now that is weird. Let's put this lower. Then it's gone. Let's put it higher. Let's put it higher here. Yeah, something. Yeah, I mean, it's fine though. Should work, but it's gonna take a long time to process. Yeah, it is working. It's fine to have like that one point here that is not entirely working. At least it is working somehow. Yeah, like that line is fine. It's gluing it anyway. We just need fewer intensity in the resample. Give it back to 50. And go back to glue. Let's view glue. Let's view volume. Let's go back. Bake again. Yeah, this should do it, basically. Yeah, this is a nice, decent value. Cool. Yep. Let's play it from the beginning. Play. Haha, it's way too fast. Yeah, I bet there's a way to make it slower, but for now, this is working. All right, cool. Let's have some fun with our simulation. Let's go back to probably advanced. No, simulation, that's fine. Forces. Oh my god, there's so many things to play with. Friction, wind, cool, gravity. All right, we have solver, and in solver we have something called constraint iteration. If we read constraint iteration, it says within each substep, this number of passes will be taken by the constraint enforcement operations. Stiff constraints can require more iteration to coverage. A good starting point is the diameter of the geometry, the number of edges between the farthest point. Cool. I didn't understand anything, but if we take that number to something like 5, all right, and now we go and resimulate things, we see that it goes way down, way lower, and I think we need more points in order for this to show properly. So resample, give us your blessing of 150, and same here. Give us your blessing of maybe 60. All right, and so we have given the blessing. We've been given the blessing from our constraints. Here we go. The more numbers, the more of this iteration will happen, and now it looks like cheese. See, it's just doing constraint iterations to 5, and now it's quite heavy in the middle, and it just keeps going. Like, it doesn't respect that this is a rope, that it's been tied together. So basically we want the opposite effect of that. So instead of a 5, we need probably at 850, something like that. Let's go back, re-bake that, and it will take a longer time because it's doing the iteration over and over again. But we see now that it's respecting the constraints between these points. Before it wasn't. It was just, respecting them 5 times. Now it's respecting them 150 times. So let's play that again and show you. Yeah, that is exactly what a bridge could act like. Now we need our blessing for the resampler here a bit less, in 30 maybe. Let's take the number to half. Same thing here. Boom. I mean, 150 is like 160. Well, 150 is like, let's see, 75. Yeah. Let's break it again. Break. break that, 75. And go back here and rebake that thing. All right, so let's rebake. And it should work, yeah, for us. One more thing we could change, and let me check where that is. It's most likely in the glue though. There's the glue search, fine. And let's stretch right there. And we could play with those values, with the stiffness, of course. We have played with that a little bit now. How stiff is it? Topic radio rests, length scale, this one. We'll see what it does now. We'll learn more and we'll be right back. We basically forgot to do the constraints correctly, so I duplicated it and I put it in the right groups. The first constraint should have the diagonal group, and the second constraint here should have upper and lower rail. And for example, if we make now, and that we've done that in order to control. So the more control we have, the better. And so for example, if we are playing with our scale here, with our stiffness, and we've added that into 10 maybe. So those are the upper and down rail. So they are quite stiff now. Wait, give me a second. I don't completely understand this. Let's check it out. So there's something called rest length scale. And it's actually an attribute. If we go to our constraint geometry. Constraint tag damping ratio rest length right there. Our highest number is 128, and if we maximize that, it will do a different type of simulation. Let's just try to understand what type of simulation would it do. Okay. We'll do something like that. Whoa, everything is super not stiff, let's just say like that. That's like a what is called a fishing net. A fishing net might look like that. So that is the opposite of what we want. Let's just play it fast so we have an idea. Yeah, that's like a fishing net, honestly. So our strength here, our scale, sorry, in this part will make that less stiff. And so if we make it a 0.2, it will be super stiff now. Let's see what that means. Super stiff. Okay. Play. Yeah, it's barely going down right now. And that is because that constraint works with upper rail, lower rail. Perfect. That's exactly what we need. We need the upper rail and lower rail to stay and become stiff, because they are in the end connected with 1 point. I mean, with 2 points, with the pulse. They should not move as much. So now we know the 2 extreme of this. So let's go with 6.5 and play our simulation. Still completely stiff. We don't want that yet. So go up to 8.5. Let's check how that works. Let's go back and play it again. Okay. Are they even working now with the simulation anymore? Or are they just super stiff? One way to find out. So 9.5. How would that feel, my friend? Play. Yeah, they are going down now again. 99. Let's go back. Vellum solver. Go down. 99. Yeah, that is about the value we're looking for, because the bridge should not just fall, it should stay. And so that's a good value for now. Let's play that again. Yeah, what I don't like how how not stiff our walls are, so let's make them quite stiffer. So we'll make this 10 and the same thing. And now we will add much less, actually more, into the scale. So they are going down. but not too much, hopefully. All right, so let's go back, simulate that again. Okay, yeah, kinda is what we're looking for. Yeah, I like the wind simulation we're getting. Type of wind simulation a little bit. Yeah, but it's not totally correct. Why is it doing those, values? No idea. Let's check it out. Excuse me. Let's go with something lower in here and check if that would solve anything. Yeah, it's doing that. It's going into it itself. We don't want that type of deal. Let's check, maybe because we went over the one, we are facing problems here. Let's go with 0.99. Let's stay beneath the one and check if this effect will be now backwards. Yeah, okay. Yeah. Let's just keep it simulating. Actually, is my video getting slower when this is happening? Just wondering. Let's check the stream. Going in. Let's see if my video is slower. I'm just gonna move a little bit. No, everything is working. Perfect. Okay, so we let that go. We let that simulate. So let's check it out. Let's pause. Go back and play. Yeah, it's resting. Good. Play that again. I like this. It's, however, having way too many points to work with. So from the side, it's completely obliterated. But I like it. It's like, if there were planks, I could totally see it happening like that. But it's definitely too much details to work with. So let's go back to 15, half of it. And now let's simulate that again. Let's go back. Play. Let's look at it from here. Yeah, that's better. Cool. I like this. Awesome. Let's play it again. Cool. All right. This is awesome. I like this. Good. Let's play and watch more. Okay, now we understand that, in a bigger environment or like bigger bridges, we would have the upper part. Let me do a screenshot so I can explain that. So what we want to do eventually, let's open a snipping tool. We want to achieve that look when we let's go with the red. So this, in a real life scenario and a bigger scale scenario, would have this thing quite stiff, right? Stiff. Here we go. But this one will be less. So it will be basically, what's the opposite of the word stiff? Not stiff. Not stiff. Okay. And so it will fall further. We'll go like that. And that is what we're going to do. So how to do that? We will separate the upper rail from the lower rail with their constraints. But in order to do that, we need to separate them entirely. Now there's a way to do that because we already have separation, I believe. Could be wrong because we've added our group, so let's bypass that. Let's not bypass anything yet. So this will be, okay, let's copy that, paste it again, and put another one. Let's name some stuff now. So this will be, what's happening here? Let's copy that, paste, put it right there. Let's call this constraint up. This will be constraint down. And this will be our constraint rails or walls. Let's just call them walls for now. And this will be our glue. Glue on rails, our wall. Oh wait, glue wall on. Up and down rails, whatever. Let's just make it long. Yeah, let's be satisfied by that. Because it was quite a thing, so I'll just separate it on the right side there. And so we have our up and down. Skip those together and then keep the rest different. So how to separate those? So diagonal rope. Wrong, we need our upper rail. Here we need our lower rail. Maybe I copied the wrong stuff here. All right, this need to go, and we'll put our diagonal rope. Here we go. Now the simulation will be completely different, unfortunately, but let's look at it. Not that wrong, because the values are just so similar. Fine by me. Good stuff, honestly. So let's go here. Our down rope should keep its stiffness, so to speak. This here will be less stiff and we'll get a higher scale. And then we'll see how that works. Well, let's go back. We just wanted to be going a bit lower. Yeah, it's going lower than the bottom one. Here you go. But is it going much lower? So let's pause. Let's take it to the side view. Here we go. This is going almost a cube down. This is going almost a cube down. So there's not much really going on yet. So let's take the stiffness here quite more. I mean, the rest angle scale. Now I put it in an extreme level. Let's see how that affects things. Yeah, half a cube basically. Let's see. Gonna take a screenshot to see if there's any difference. Let's play it again. There's a difference, right? Let's see. One. Just examining. The lower one has been gone now lower. Yeah. Well, are we playing with the wrong stuff here? Up. But is it the upper one then? We don't need diagonal rope, thanks. Same here, we don't need that, thanks. Is it back again? Okay, finally. Let's play that again. And check if it puts it again. Yeah, that's better. That's actually working. Yeah, it's lower now. Okay, we're doing something, people. Cool. How can I make our connected ropes, the diagonal ropes, stiffer? Let's see. We will need to put this lower and play that again. Whoa, way too stiff, buddy. Let's make it on 0.8. Play that again. Too stiff. Let's put it on 9.3. Play that again. Stiff. But it's not too stiff, at least. Alright, go back again. Make it closer. Play. Oh my god, that is bad. Ugh. So we need less resolution. Resample. Take your 16 backwards, please. Here we are. Yeah, that's way too many points to work with for now. I need it to be stiff, so we gotta put those back. Play. It's not stiff at all. Doesn't look like it's holding anything. That is bad. I feel like we did put the resolution now quite down. Let's check our diagonal rope. So diagonal rope needs more stiffness. So let's go with a value of 1.2. Let's check. I mean, this will be even less stiff now, right? It should be the case. Yeah, it's going even lower. Then we have to respect the 0.8, I guess, and check how that works. Let's play it again. Hey, Sandy. How's it going? Sandy, right? This is how you spell your name? How's it going? Let's just, yeah, right there. So anyway, let's play. It's too stiff because it's taken it with it. Let's try 0.9, but that will also not work. How are you? Good. How are you? I haven't seen you here. Where do you know me from? Okay, so that's just a question to make sure that no scam is going on. So let's go here. Still very, very, very. How can I make this more stiff? Wrist length. Stiffness is the one. Is it the lower? This not. What happens if this is a 2? Still not stiff. Is stiff what we're looking for anyway? Is the word stiff is what we're looking for here? What does the damping do if this was on 0.3, for example? What does that do? Let's go back. Okay, still very not stiff, so to speak. Let's go into a closer value to 0.8. Aha. Are we getting a stiffer version? 1. Let's go here. Go back. Damn. Damping. Yeah, we had a 0.1 damping value. That's mind-boggling. What is happening? Why is this happening to permanent normal drag? Is that the drag that we are not willing to have? Let's check that out. Play it here. I just think it's way too many points, honestly. And is that playing a role here in the respect constraint iteration? Can we put up 2500 and how would that look like? No, nothing is changing really. Okay. So let's put this down to 700. Let's take that, go back here, and let's go there. No, there. Upper rail, lower rail, diagonal rope, and constraint wall. I'm trying to think here how to solve this. Normal drag. Well, that was on 10. Let's keep it on 10. Let's go to the easier way to do this. Right there with adding just 1 point. Let's just see how that would look like. I feel like it's gonna look like not so good. Let's see it in 3D. Okay. Yeah, I don't like this. This is not going well. What can I do to make this? And maybe we did make this thing go a bit too much down. But I mean, let's keep watching the video. Let's do that then. Let's check it out. So what we'll do is put it to the test, honestly. So what I don't like how this is going, you know, it's too less anyway. Let's add 8 points here. Let's check how that looks like in here. So play. It's too less. It's too. How did I do it to make it more stiff? Wait, is that something we could do in the down here? In the upper one, let's check. Wrist length, there we go. Wrist length. This one is good though. Okay, let's check the wrist length again and put it back to something like that. Let's see how that would work together with our inner rope. Yeah, this is giving us a better result. Okay, so now we have to focus on other things, guys. We need to put this into the output. So where is our sweep operation? Sweep operation is rope gen right there. Let's put the whole thing into a shift S. Oh, sorry, shift C. Full events being dropped. What is happening? Wait a second. Put it in the one. Did we break it? All right, no, we did it. Clear, close. We still have the operation going. Good stuff. We need now to focus here a little bit. We have an error, I would see. Now it just says that there's a simulation. Let's delete our attributes. So delete attributes to clean it because we have a lot of stuff that we might not need. So let's just delete everything from here. Delete, 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 delete. Okay, and let's put it in the rope gen. Check that out. It is not working at all. Nothing is showing up. Okay, maybe not delete the vertex attribute. Okay. All right. Rope gen is completely broken. Okay. It's broke completely now. Man. Let's just put it without deleting anything. How does it look like? Completely broken. Okay, wait a second. Gotta watch the video. We'll be right back. Okay, so we found out the problem. It's good to do a revision anyway. So we went into the subnet. And into the subnet, we noticed that basically our walls needed to be first, and then the up, and then the down. And then we have our glue that worked. And this actually brought back our constraints here because before they were gone for some reason when we were questioning why that happened. So now they're back. And also I noticed that if we look on the side view, we notice that the down one now is going lower and we needed the upper one to go lower. So maybe we can fix that right now. We just need to switch the values here. So that's a 1 and the up is a 1.6. So basically we most likely are not putting this correctly. We need the other values the other way around. Okay, so this is a 1. And the up one should be a 0.6 in this case, I guess. Let's play that again and let's make it simulate again. All right, so we will wait for it. We need the upper one to go lower. And let's see, check if that would work. Good enough for now. Yeah, it is definitely going lower here. Could go even lower, but for now, it should work. Let's go into hierarchy before that and check our generation with +1. I also have added an attribute delete because in here, if I hover over this with the middle mouse button, there's tons of attributes that got created, almost 30, and we took it down to how many? 2 primitive attributes and 1 point attributes, and this is because we just deleted those things. Just went in and deleted everything, and then we have our rope gen that is working. We just need to bring back our nuts, and our nuts will probably, we'll see about them. We'll see how they will work. We probably need a constraint for them. We also need to apply that simulation to a lot of the stuff, but for now I would say it's working. Let's go back and simulate that. Here we go. Yes, this is looking very nice. Let's play that again. Yeah, cool. Let's stop that and check for the rest of the video. Okay, guys, so we'll try to explain what's gonna happen now. We will work with our planks again. Yay! So there is a technique we will use in order to simulate them, and I'll show you that technique as we go. So first we need the null for our basically for our planks. It's going through here. Let's view them. That's one of them. We need them right after the copy, which is happening here. Now we see that it's the enumerate, and we know already that the enumerate is made from points, or the group type is points, and we need that into, wait, sorry, it's an integer, and we need it to be a string, and let's just hope everything works still. We'll take the value from here, make it into a null, and this will be our planks full out. Okay, so this is our planks. They're fully developed and they are out, and let's get that into our simulation, which is happening right here. Let's give it a red color because it's a simulation. It's calculation of some sort. Let's put that into input 2. Let's go inside. All right, let's go out, take our inputs, put them there. Let's save our file. Good. Now we need to create a technique called Vellum shape matching, which will create a vellum grain out of our plank pieces, and then it will use the grains for our simulation, and then we will take the transforms that are applied from that simulation into, okay, that's a mouthpiece right there. All right, so third step is that we will transfer the transforms that are created from the simulation into the pieces back again. So let's see how that is done. First of all, we need a node called pack, and so we will pack the red pack, this one looks like flashy, looks like an explosion. So we'll pack our stuff, and then we will create a vellum grain, volume. What is it? Volume. What is it? Vellum unpack. All right. So double L volume grain configuration. All right. So we'll put that right there. And I just wanted you all to know where we are right now, so we'll learn some more and we'll let you know how this whole thing works. Okay, record that real quick. I forgot one more step, and that is basically we will use the pack to create through an input that is the index input that we put, and this should make it work so far. Let's see. Why is the index not in here? Okay, now we'll check why that is the case. Why we think that's the case. Where's our index? We have a UV index, it's right there. Okay, is it what is it, an integer? String, yeah, okay, cool. Pack, good. Nothing inside of here. What? Null? Put that in here. What do we have? We have index string. Okay, so what is the problem? Is it written with a big I? Our pack should work with an index like that. What? Full I. All right. Wait. Full geometry. index, centroid. All right, so everything is configured. Let's go back actually to our enumerate. So index, group type, maybe primitives. Nah, this will not make it work. Index, string. What happened there? Why is it grayed out? So let's see, index, string, 19 unique. I must be missing something. Give me a break. So that was what's wrong. It didn't know what to do with the index because it hasn't been processed before. So let's take our null down there, all the way down there. Let's take it out of the UV thingy because, yeah, otherwise it won't work. Makes a lot of sense, but yeah, doesn't matter. Let's check what we're gonna do. Why does this have two outputs though? What for? Wait a second. What do we have at the end? Just a normal output. Alright, let's check the null. What does the null do here? Check it out. What does the null do here? Let's check it out. Okay, it's splitting the geometry, so like this. Let me see, maybe that is what we need to do. So let's hook that up in our simulation. Let's go. Okay, and so pack is working finally. Okay, cool. Let me check if the ropes are connected in his version or not. Okay, we'll be right back. All right, so it is the case. So let's go back here. Let's add the null after the merge, I would say. Should be fine. Let's add it here. And let's take it, put it in input 2. Okay, cool. Let's take that thing up there then. Oh. Yeah, good. Still connected. Good. Let's see. It's connected to two things. All right, so let's check this out. I kind of want this connection though to go from, yeah, it doesn't matter for now. We will take that if it's working. Yes, it is working. Good. Then it is working. Let's go over what we have learned so far. Okay, so 1 by 1 jack. Don't overdo it. So we have made our pack work. So we have our volume constraints grain. Okay, so what does that do? What the hell it does it do? If we connect it and view what it does, we will have almost, yeah, the same shape. Everything is going well, but well, just like anything else, we need to configure this. What we'll do is we will create points from volume. So basically whatever we have here as a geometry will become points so they can simulate properly. And this will get messy now. So click and boom, here we go. We have points from our volume. Looking pretty cool. Reminds me of some Blender stuff. All right, so regular grid, we'll go with sphere packing. So we can pack as much things as possible. Right now it's not working because we need a max and a minimum radius of sphere. We need that sphere to go, buddy, you need to go from 0.5, maybe from 0.5 all the way to 2. Maybe all the way to 3 even. So just feel free. And now it just will fill those spheres where it is. Minimum radius. Okay, so it's an integer. So let's go with the, yeah, let's start with 0. It doesn't matter. And we have a particle size, and that one we need to put up to something lower. So we have the pack going, okay, wait, overlapping, we should allow that. And then the point counts, okay, but why is this not working? Let's put this back to 1. Type grain, yeah, good. That's exactly what we need. Let me check my, so we activated define pieces, check method sphere. Here we go, sphere packing, correct overlapping, correct maximum radius. We have done that. Particle size, we can't change that. We can't change the maximum or the particle size, but we could change is the point count. that is doable. Maybe this should stay at 2. We just can't do that yet. Maximum spheres, that won't work. Physical attributes, nothing. We can't change. Here. No, we can. So 0.5. Why is that not working? 0.5. Yeah. A bit lower, maybe. Ooh, 0, 0, 0, 0, 1. Is that a value acceptable for you, Houdini? It's loading. It's loading a lot. We will just wait for it. I'm gonna pause the video. Here we are. We're back right. Yeah, it happened. Let's have a 2 here. Check what's gonna happen. It's gonna load again. What do we need? Maybe we do have bigger spheres. Maybe 5s. Check what will happen now. Keep that number a bit lower, maybe. Let me just check. Yeah, let's keep it to a 10,000. Fine. 1, 2, 3, 4. Good. All right. Let's let that load and wait for it to happen. Yeah, we have kind of the same workflow. Let's keep that on 1. Let's check if this would actually chip it up better. Let's see. We will wait and wait and wait and wait, and then it goes. Here we go. Particle size. Let me think. All right, give me a break. Let's go through it. This is just the size. So if I put this back to the same value he has, 1 and 3 for scale. So let's put this back to 3. Not 30, but 3. We should have a similar result, but we're not, though. Trying to understand what is happening. Let's try grid again. I don't know. I kind of feel like this is doing a better job in this. I mean, it's definitely working better for him with the sphere packing, but for us, it's just not working. And I'm not, like, I'm doing the same settings. It's just different for me. Maybe they updated it with a new version or something. So let's go with the grid for now. Let's check particle size, put it down to 3. This is like pixels now. We'll have more details with smaller values. Pack density 1, seed. Okay, let's just keep it like this. See what happens afterwards. Not sure. All right, so we'll see what's gonna happen. We'll be right back. Let's check that out. Actually, I'm not sure how well that would work, honestly. I feel like we added way too many in a Vellum grains, so let's add bigger ones. Yeah, let's just keep their size to point. I mean, that's just way too many. That's the difference between the grain and between the grid and the sphere packing. And sphere packing is taking way less space. Just trying to understand in ISO value. Let's put that to 100. Let's wait, see what's gonna happen. Let's see. Yeah, it's loading. Ooh, even the stream is taking a hit. We'll stop the recording. That. Thank you, Omar, for the subscription on YouTube. I appreciate it. Let's go with, let's see. We just don't have. So what I solved is our ISO value is now at 0. How did it work? It doesn't do really anything different. It just puts them outside of the geometry. We don't want that. Let's put them on 0. Let's click back again here. We need to add more points eventually to make it work. Yeah, so more points definitely give us the same results he's getting. So let's go with 35,000, something like that. Yeah, it's overlapping. We have minimum sphere of 1, maximum sphere of 3. Let's try with 4. Yeah, okay, that's even a better result. Let's keep it up like that. Good. Now we have created a grain. Okay, now what do we do with the grain? Now we need a constraint. So Vellum constraint, and now we will see what we do with that. That's a really complex thing, Vellum constraint. I still have to wrap my head around it, so let's check it out. First, we need to do in that is, well, we need to shape match. Okay, so let's see what that means. First thing first, let's go all the way up. Constraint type, we have distance along edges. Before we used string, and now we will use shape match. So shape match, and now it will match its shape, so it will become one thing, one geometry, so to speak. Then we need to define pieces from, let's check that out. Define pieces, and instead of from connectivity, we need from attribute, and we need that attribute pieces that our index actually created for us when we have switched it into string. And if we go like here, we middle mouse button click, we will see something called index strength string, and it has 19 pieces. Let's see, UV coverage distance, blah blah blah. Let's go back. Actually, I saw it. It was in the enumerate. It was right here, and it had called it piece. If we just click on that, check our detail here. We have point number not. This one is in the detail. Where could we find that? Let's see. Is it here? Pieces. Let's see. Pieces. Piece, group, start, end, up, z, up, y, up, x, scale, piece scale, out, name, normal, index, and here we have the piece 1, piece 2, but maybe it's a new attribute, honestly. Let's check it out. Double click here. Let's check our attribute from here. We have our position, and here we have, okay, let me just put this a bit to the left so you all can see it. We have I is grain, integer, mass, float, p scale, float, v float, which is the vector, and we have gl sphere points as a detail attribute, and the rest. Okay, so where do we get our piece from? I bet it's from, I kind of guess it's from the index, honestly. So let's just go backwards in the video. I'll keep this in the recording just to see. Yeah, it is the piece, so it is made by the index itself. Okay, now the next step is to, I'm just gonna rip this off. Here we are. The next step is to get a group type and put it into points. So where are our group type? Right here, group type. Instead of primitives, we will go with points. And we will go now and create our Vellum solver. Here we are. Let's check what happens when we have to wait. When we hook it up, here, and play that part. Stick it back. Okay, something is not happy with our decisions here. Let's check, let's view it. Yeah, okay, it's not viewing anything. Nothing is coming out of this one. Why though? I must have missed something. Okay, so pause. Check if this had worked for us, because when we have changed it into group type points, it should have connected to the points. But in our case, for some reason, it didn't do that. Primitive points address. It should have connected the points to each other, and this is what we're missing here. Right there, right? It should have happened here. Let's check our points. They are all over the place. Let's check our W. Wireframe. Nothing is getting connected. Okay, let's pause to remember them in the future. Okay, so we don't have piece here. So we were referencing an attribute that didn't exist. We only have p scale, v, mass, or is grain. Those are all attributes we can't use for the volume constraints for it to work. So what we needed is in the physical attributes to define pieces from connectivity, which should have given us the ability to have the piece here, because now if I right click or middle click on here, I should have the ability to transfer piece attribute. This one, we should have piece attribute right there. All right, so that's the thing we forgot. And here we have piece attribute looking well, and group type points. However, why are we? What is this? Let's uncheck that one and write it again. Piece. It's going all over the place. Reason for that, let me check. From attributes, nah. Piece, nah. Let's check from connectivity. Transfer point attributes, but it's not connecting properly. Is this connected to the index? Yeah. Create packed fragments. Index is here. It's a string. Okay. Index is here. And this is creating. All right. What happens if this was down to not 1,000, but 10,000? And then I went here. Pieces are they're still connecting in a weird way. We don't want that though. We want it to connect in each plank. Let's see. Let's keep watching. Maybe I missed another step. I must have. So yeah, just gonna keep watching. Okay, so far Houdini crashed. I have removed that subnetwork because I think our output was wrong, completely wrong. Let's take our output from here into a null right there, and that null should basically just go into our. So we lost a lot of progress, by the way, but that's fine. It's good for revision. Let's put it right in at the top of here. Plank full out. Let's take the same name. Delete that null. Put the thing in the second output. Let's hide this. So put it all inside. Let's go back into our enumerate. Put it in the string. Index points. Good. So far it's good. I'm just gonna do this real quick. We're probably not gonna finish this video for today, but just gonna try if this thing works. It's fine. It's getting really late, so I need to stop soon. Okay. We need a pack. All right, so we did that pack thing. Let's go inside. Let's see if it works, and let's see if it would work with our index. Here we go. Index is working. For now, we lost our. Yeah, let's do it without them. We can maybe add them later. Okay. How do I do this? Let me think. Let me think. We can do this through. Okay, so we need a. What is it called? Grain. Let's get the grain. Configure grain. Damn. Good. Let's put it in it. Take its grain, change the method to points, and create points from volume, and get sphere packing, get that to smaller value, and enable a max radius and overlapping. There we go. And then we need to do it from connectivity. Here we go. Now we're getting the deserved result, and we need to transfer piece attribute. Okay, so that will give us the ability to add a Vellum constraint. All right, so let's start clean, connect the constraint, and now the constraint first thing we will we'll decide its constraint type, and we will go with shape match, and we'll connect the points, and we'll go from attributes, and we'll take our piece attribute, good, and our group will be points. Yeah, points group. Let's see in the W. They are not connecting yet because I don't view. All right, now it's working 100%. That's good. Save that. Add a Vellum what is it called? Vellum solver, because it solves the problem. All right, so that is our Vellum solver. Boom, connect that with this. Here we go. Good. Let's view that and let's play it. Where to play that? Let's check it out. Why is it not taking the data though? We must be missing one or two settings. Let me basically we need to go into advanced, and in the OpenCL we need to disable this neighbor search because it won't work with it. Yeah, the rest, there's still one more reason why it's not working. I still don't know what is not working here. I must have missed one thing or two. Group type, point, volume solver. All right, so yeah, that is basically all what we need. Let's go back to 0 and check if it's working. It's gonna load. Wait, let's view the volume. Yeah, it's going down. It's going down for real. Cool. Okay, now we could add a ground, for example, in the solver. I think collision, yes. Enable collision, self collision, and ground collision. So ground position. Let's add that ground collision to -5. Actually, yeah, that's about right. Let's do it again. Now it should collide with it. Boom. Good. Yeah, that is all for today. I need to wrap it up, guys. Yeah, thank you all for watching. If you're watching this on YouTube or on Twitch, today we tried our multi-stream for the first time. I will pretty much keep doing that in the future. We'll just refine it a little bit because I wasn't getting your comments or anything. We'll find a better way to do it. To keep everything in one setting, hopefully. All right, so it was enjoyable. It was a lot of work today. It was 2 parts of videos. Damn, that was a lot to do. Today we did indeed complete our texturing with the wind here. Yeah, things are looking good, and we have done some simulation. Those simulation were right there. Yeah, we're not gonna view it for now, just so Houdini doesn't crash. We will save everything, and thank you all for joining. We will continue on Friday, so after tomorrow is off for me. Yeah, we'll see you soon. Thank you for joining, and see you on Friday, so after tomorrow. All right, people, bye. Bye.